Hello guys, this is Shakti and I am PG scholar in Veltech University. So this is my final year project. The title is Geographical Image Retrieval using Spatial Filtering for Image Enhancement Techniques. So these are my guidance or Harihan and Srimadi he is one of my HODs and Prasanna. Then I am going to go on my abstract. Geographical image retrieval problems are unique to image processing, weather forecasting, and related fields. The image sequences taken from airplane, satellite, radar, unmanned aerial vehicle image that contain noise, blur extraction due to climate changes, night vision, cloud, airborne, rainy season, and unconditional climate. The capture contains information in unknown format. So, to retrieve the information present in the image, even though if the image contains noise, that's this paper proposed. A method to give us good informative image on above conditions. Selectively first, I am going to use advanced hypothesis selection filter. The filter are nothing but a collection of filtering techniques like nonlinear, linear, just spatial filtering techniques. The next one is Gaussian for the process of removal of noise, blur, salt, and pepper images. Okay, this will provide the tracker to get normalized images. Another one, contrast limited adaptive histogram equalization for night vision images to get the better normal image information. So also it will use to the better contrast image in the sense. Furthermore, the gap filter it performs the weather forecasting conditional image analysis and content-based image retrieval from the database. And these are my keywords: hypothesis selection filter, contrast limited adaptive histogram equalization, then GF in the sense Gabor filter, SPF spatial filtering, nonlinear linear selection filter, and content-based image retrieval CBAR adaptive histogram equalization. And this is what my introduction. Nowadays, we observe a meta amount of images retrieved from satellite and other sources that are stored in electronic, in the sense digital and frequency format. The survey of geographical image enhancement process has been increasing explosively and analyzing the image research area on weather forecasting community. This paper classifies the various geographical image retrieval processing likely follows the hypothesis selection filter serves a framework for combining the output of a number of different user selected filter. Each one best suited for different region of an image. Contrast, the next one is contrast limited adaptive histogram. It has the better contrast, then image processing is used to determine the better visual appearance. Nowadays it's difficult to get good visual images because captured image contain list of unconditional format due to illumination changes, night visions, and unpredictable climate conditions causes noise, blur, and etc. The digital image process gives the better enhanced techniques for types of image to get the desirable information in that one. So some of the filtering technique is produced to better enhance the image to the user to get the appropriate information within the image. So the advanced hypothesis selection filter in the sense nonlinear, linear, and Gaussian, and etc. And next one is contrast limited adaptive histogram equalization filter are used here to get good visuals. Then next one is image enhancement process like sharpening and highlight the features such as edge, contrast, extraction, and boundaries to reduce the draining artifacts. So one of the most difficult process in image process is to obtain the satisfactory result. Then the digital image process plays a virtual role in most of the fields like medical, military, microscopy, and telescopic imaging. Most of the geographical images are retrieved from the unmanned aerial vehicle. This is going to capture the image with limited range of distance only. But the microscopic telescopic image enhancement process gives the better enhancement image compared to other image enhancement filters. While using this kind of filters, we can easily avoid the noise and identify the exact information within the image as well as weather forecast image analysis. This type of filter going to give the better resolution image to the tracker. For example, an image with different climate conditions. This is the sample image. First image is this. The same image with the different conditions: fall, winter, and spring, and raining season. Then move on to the. This is what my modules. The image enhancement by using hypothesis selection filter. It's nothing but it's a new image enhancement approach for combining or collection of filtering method that the output of distinct filters combining of each other, which is choose to prove particularly type of content in an image. Our main aim is to combine the filter output and to obtain overall best quality result over the filtering technique was. So this is what my architecture diagram. First I'm going to explain one by one. This is what my image source is, the image database. This first one is image module, then second one is the processing module, then final step is output module. So first input modules, we are going to get the input from the image source. Then, so based on the image, we are going to determine the error image based on the template image and the target image. So we are going to fix what type of image we are going to retrieve, and based on the image retrieval, based on the input image. The next one is we are going to apply the hypothesis selection filter. This is what in the sense we are going to apply the characteristic conditions. Then second module in the sense processing module. So this is what histogram equalization filter. This is also in the contrast limited, and this hypothesis selection filter is a collections of combination. The collections of filtering techniques we are going to apply. Then this one histogram equalization contrast limited, and the next one is contrast limited adaptive histogram adjustment. This processing module we are going to apply the contrast conditions. Then final one is Gabor process, and finally we are going to get the output module. Finally we are going to get the exact output module. So what I'm here going to determine the error image based on the template image and the target image. So this is the expected output image we will get. Then first one is spatial domain. This is what in the hypothesis selection filter, nothing but I already told. So collections of combination spatial filtering techniques. So first one is spatial domain. So which is operated directly on 12. 12 is nothing but is a pixel. So pixel is the smallest element of an image that stores a value proportional to the light wise, in the sense object or subject wise at the particular location. Spatial filter has two major filtering methods named linear and non-linear spatial filters. These filters have been from frequency domain. This filter can be classified into furthermore categories. It preserves the low frequency and high frequency. It preserves frequency within the band and it rejects the frequency within the band. So some of the image enhancement techniques that we are going to discuss later. These are some of the enhancement techniques: histogram specification, and dynamic histogram equalization, edge adaptive hybrid filters, then adaptive median filters, then effective median filters. So this is what the spatial domain has following types of filters. First one is linear filter, then non-linear filter. In linear filter are used to remove some types of noises. So what in the sense they have what my input image have poor performance in removing signal dependent noise. The output of an image wider sum of the input pixel. So it has two linear spatial filters, correlation and convolution. So these are the mathematical functions. So this is often used to find similarity matching between them, images or some part of an image. So this is also called as pattern matching. So this is what my correlation mathematical formula. Then next one is convolution. It's similar to correlation, but the mask is flipped both direction, horizontally and vertically. So this is what some mathematical example equation. Then second one is nonlinear filter. So nonlinear filters such as it's furthermore classified into median and mean filter, max and mean filter. So these process of filters have been developed to overcome the limitations and the shortcomings of linear filter. So these are the sample images for median filter, mean filter, max and mean filters. So these are the some description about mean, max, mean and median filters. So next module is image enhancement by using pre-processing enhancement techniques. So I already told you. So pre-processing is based on the contrast management techniques. So the pre-enhancement techniques is furthermore classified into contrast adjustment, intensity adjustment, histogram equalization, adaptive histogram equalization, and contrast limited adaptive histogram equalization. Let's we discuss about one by one. The first one is contrast adjustment. The contrast of an image is based on the distribution of pixels. A low contrast image exhibits small difference between the light and the dark pixel values. The histogram of a low contrast image is narrow domain because of the absolute pixel intensities. The next one is intensity adjustment. It's based on the objective wise and subjective wise. It's going to divide. So here some basic intensity adjustment functions are image negative, threshold large and transformative, then the power law transformative, then piecewise smoothing transformative functions. The next one is histogram equalization. So histogram equalization you already know, guys. It provides the global description of appearance of an image, and this provides useful information to the contrast enhancement often tried to enhance an image. So this has special requirements on operators. Uh, the output of an image should use all the available gray level, and the output of an image has approximate same number of pixels of the each gray level. Then the close contrast values are used when usable data values of an image represent. So these are the some mathematical functions I express probability density functions. Then next one is adaptive histogram equalization and contrast limited adaptive histogram equalization. So adaptive histogram equalization is nothing but a difference. It differs from the ordinary histogram equalization with respect to compute some slot histograms. Then adaptive histogram equalization, this method, each one has corresponding to the discrete regions of an image, and it issues them to redistribute the lightning values of an given input images. Also, it will improve the local contrast of an image, and adaptive histogram equalization select each center of the pixels to the neighborhood. Its handles also consists of local neighborhood of specific region of an image and mapping of 12 center values. The next one is contrast limited adaptive histogram equalization. It's based on the adaptive histogram equalization method and will remove the some threshold values while performing the contrast enhancement of an input image. This CLAH is going to apply all regions of an output image. Contrast limited is controlled and CLAH has to good contrast enhanced performance. Result in this homogeneous contrast region can be controlled and noise amplification also avoided. Once again guys, let's continue. The next module is make enhancement by using Gabor filters. A Gabor filter is a smoothing filter. The impulse response of the Gabor filter is defined to used by a multiplic harmonic function by Gaussian function of used to various and must be in image enhancement processing. Okay. The relative implementation of Gabor filter is challenging one due to the complexity of Gaussian and sinusoid. So here the some of the formula for 2D spatial Gabor filter in spatial domain. So this is what is the formulas. Then final module is content based image retrieval. So most of the image processing users, they don't know, user who do not always know that either what they want, how to express it in words. So the content based image processing is a process of retrieving image from a collections of images in the metadata in the image directory because of day by day geographical conditions are very varied due to our unconditional weathers. So this condition, the image captured by satellite or remote aerial vehicle, more number of images per day stored in directory. So this is going to retrieve based on the basis of features automatically extracted from the images themselves. So it's based on retrieve the images. It's based on color, texture, and shape. So the two classes of CBA are follows: narrow domain and a broad domain. Narrow domain and a broad domain. So this is the latest advanced one. I'm going to implement the CBA here. Content-based image retrieval formulas. CBA is equal to total number of relevant images retrieved and divided by precision and recall. So next one is CBA or FD is nothing but false determine number of relevant images minus number of non-relevant images divided by scope. So here is the description about the example. Also called. So this is also called advanced performance evaluation method. Provide the normalized performance of image retrieval process. The advanced performance evaluation of content-based retrieval efficiency and the content-based retrieval false determined. So method provide the effective image retrieval process. In CPU retrieval and stored process are slightly difficult today because the millions of images are stored and retrieved from The different tracker of image normalization purpose. So what my project conclusion? What is the result of my project is the concept of image enhancement process over the hypothesis over the advanced hypothesis selection filter. It's a collection of filter process in digital image processing, an advanced hypothesis selection is the purpose of enhancement version of filter techniques, which provide better informative image as well as fast filtering algorithm help us to get an effective result of processing image under contrast limited adaptive histogram equalization. To give the night visuals has a good clarity, further geography image analysis method are used the Gabor filter for analyzing the weather forecasting captures. And so this is what the some example images based on which kind of filter I'm going to use. So this is what the some examples. So this is contrast adjustment. So this is what the so my input image and this one is my output contrast adjusted image. The next one is intensity adjustment. So based on the objective and subjective wise, this is what my input image and this is what my output image. So the next one is histogram equalization. So this is what my input and output image. And next one adaptive histogram equalization. This is what my normal. But while I'm processing adaptive histogram equalized image, so you see you see the difference between input and output image, guys. The next one is CLHE. So this is what my normal image, and after that, crossing the CLAHE image. So this is what my output. So next one. So you are already seeing this medium filter. Some example. So after processing image, so main filter and the max filter. So this main filter. So this is one of the gap and filter examples. This is one the outcome. So this one two different images. So filtered image. Then image analyzing technique is it's content based image retrieval. It's based on the color, texture, and shape. So it's normally, for example, it's like a Google search engine. Then find the optimal solutions, the final model. So optimal classing. So open classification. So access accuracy in the sense accurate input. It will to fulfill the customer satisfaction. So based on the image data and the report. So this is what I wanted to see. So what to check. So the message my requirements and other requirements. This is for my sample coding. So I'm going to use screenshots. So this is what my screenshots. So let's see how it will be working in theoretical frameworks. So I'm going to use the MATLAB to get the normalized image. So next we will move on to the MATLAB section. So the one thing, so I'm going to develop the microscopy and telescopy filtering techniques. So using the based on this advanced hypothesis selection filtering technique. So here is the coding. So I'm going to on that one. So it seems to be error using image so file doesn't exist. Input image file, so we have to change our locations. So we will see the record. So this is what my normal image and a normalized image I guess. So this is what my normalized image. This is what my input image, and this is output images. These are my output image. So this is what my input image. You see, guys. So this is actually my output image. This is output image. After getting this one is our input image. So yeah, I'm going to use the different set of images. So this is what the microscopic filtering technique is. Then we are going to move on to the next one is telescopic filtering technique is. So this is my telescopic concept of going to change my input in my phone. It's running. So my system is moving to slow. So this is what my input image, and this is what my output image. So I'm going to use here 4 different set of Landsat images. So this is what my input, and after I'm getting this is what my output image. So this like this is input, and this is what is output image. So this is input, and I have 7 set of output image. So likewise. So thank you guys. This is what about my project. I hope this is helpful to you guys. Thank you. Thank you so much for watching this video.